Welcome to a new video from Pointwise where we highlight one of our marquee features from version 18.3 release 1. We are calling it Voxel measure. Let's go ahead and take a look at the geometry we're going to be working with today. As you can see, I have a quadcopter, and in particular we're going to be looking inside the quadcopter. We have in there a motherboard with some of the electronics that will make this quadcopter move. In this particular video, I'm going to show you how you can create a voxel mesh in that space in between the main central body of the quadcopter and the motherboard. Let's go ahead and take a look at the final result of the grid that we're going to be creating today. I think that is going to illustrate the concept and all the different explanations to come a little bit better. If I zoom in a little bit closer, you can see that we have the quadcopter, and of course we have that interior motherboard with all the surface grids already created. That is going to be our starting point. The surface grids are going to be already in place. If you take a look here, in particular, let me zoom in a little bit closer, you can see that we have the T-Rex portion of our block. All those anisotropic T-Rex cells are growing off of the surface of the motherboard. Right after the T-Rex portion of our block, we have a zipper layer. That zipper layer connects the T-Rex portion of the block with the voxel portion of our block. In particular, this zipper layer is composed by tetrahedral cells shown in red and pyramid cells shown in yellow. If you look at the voxel portion of your block right here, you can see that it's composed of several what we call transition layers. This is one, and you have another one right there. The transition layers have voxel cells of the same size. Furthermore, those transition cells are connected by these kind of like intermediate layers, also composed by tetrahedral cells shown in red and pyramid cells shown in yellow. If you keep on going towards the bounding domains, you can see that there's also another zipper layer connecting the voxel portion of your block with the outer unstructured or structured domains. In our case, those outer bounding domains are unstructured. This is the general structure of that interior voxel block that we're going to be creating today. Now that we know the kind of geometry that we're going to be working with and the general structure of the interior voxel block that we will be creating in this video, let's take a look at why this capability was added to Pointwise. So what was the problem that we were trying to resolve? When you compare hexahedral cells with isotropic tetrahedral cells, well, the isotropic TETs do not provide the same level of simulation accuracy, and that is because of their lack of flow alignment. Also, to capture flow features with the same level of accuracy, you have to increase the number of tetrahedral cells in critical regions. And of course, you know, more cells mean larger initialization times and larger simulation run times. And of course, that is something you do not want. So that's the kind of problems that we're trying to resolve here with this addition. So what is the solution? Of course, generating more hexahedral cells to increase the solution accuracy. Voxel volume grids provide a way to create more hexahedral cells. So what is the new addition to Pointwise version 18.3 release 1? Of course, voxel cells themselves are not new to Pointwise. We already had the capability of creating voxel refinement blocks in Pointwise version 18. Of course, voxel refinement blocks do not contain interior faces. So in the case of Pointwise version 18.3 release 1, you can use the new voxel measure to fill the isotropic portion of T-Rex blocks with hexahedral cells. Also, you can fill purely isotropic unstructured blocks with hexahedral cells. In the image to the right, I'm showing the two ways in which you can set up the appropriate isotropic algorithm. If you go to the defaults panel right here, you can actually see that inside the isotropic blocks frame, there's an algorithm option with the pull down list with two options, Delaunay and voxel. In our case, we're going to use the voxel option. Also, inside the grid solve panel, in particular going to the attributes tab, you can see that they have the exact same algorithm option with the pull down list. So let's go ahead and create this interior voxel block. We are starting with the quadcopter. As you can see, all the surface grids have been created. In particular, Let's get a little bit closer so we can take a look at that motherboard and the surface grid that comes with it. So the first thing that you have to do is set the appropriate orientation of your model. In my case, I'm going to orient it this way for an easier selection. So once I have the appropriate orientation, I'm going to go to Create, Assemble Special, Block. Keep in mind that you can access the exact same panel from the Create menu. Create, Assemble Special, Block. As you can see, right here we are inside the block assembly panel. Let's go ahead and assemble our block. I'm going to select all the appropriate domains for my block. Assemble face. As you can see, the block has already been assembled, and if you look a little bit closer, all these normals are actually rendered. And it is important after you assemble your block to make sure that all the normals are actually pointing into the block, into the volume of that block. And as you can see, that is certainly the case over here. Hit OK. And our block is now assembled. Now that our block has been assembled, let's go ahead and select our new block, Grid, Solve. And if you go to the Attributes tab, you can see that there is a new frame right here, which is the Voxel frame, and it contains 4 options that will allow you to set up your Voxel block. The first 3 options are the main edge, the max edge, and the transition layers. And as you can see, the appropriate text fields next to each one of these options has been pre-populated with default values. In particular, the first 2 options, mean edge and max edge, those default values are computed from the size field that has been pre-calculated for the block that we just assembled. The transition layers option has a default value of 3. Of course, you can uncheck the appropriate checkboxes right here if you want to define user-defined values for each one of these options. In our case, we will use the default options. Last but not least, there's a new alignment option with a pull-down list that contains 2 options: alignment, axis, and alignment body. You can use the alignment options to indicate whether the Cartesian style hexes should be aligned with the coordinate axis, and that is the default behavior, or if the voxel topology should be aligned with a computed body primary orientation. In our case, we will also use the default option. It is now time to set up the TRX boundary conditions, and even though this is nothing new, I want to show you what is the most efficient way of doing this in this particular case. So let's go ahead and switch to the Boundary Conditions tab. As you can see, there are 2 TRX boundary conditions that have been created already. We have a wall TRX boundary condition and a match TRX boundary condition. Now, let's take a look at our geometry. If we zoom in closer here, you can actually see that the motherboard is actually comprised of a lot of smaller domains, and obviously we don't want to set up or select each one of these individually to assign it to the appropriate TRX boundary condition. So what is the best way to actually set things up in this particular case? Let me go ahead and zoom out a little bit. And here's the best way to do it. Select one of your domains, one of the domains in the main body of your quadcopter, and then you can see right here somewhere in your toolbar there's one option for the angle limit. I'm going to set that one to 60 degrees, and then I'm going to go to select all adjacent. As you can see, this is quickly going to select all the domains adjacent to the domain I selected first. If you zoom in a little bit closer, you can see that all the domains forming that main body of the quadcopter have been selected. However, none of the interior domains, those domains on the motherboard, have been selected. So once you get to this point, you can do Control T to invert your selection. And now you can see that all the domains on the motherboard have been selected. From here, it's pretty easy to finish my appropriate selection. I'm going to unselect these 4 domains right here. And as you can see very quickly, I have all those domains already selected. I'm going to assign them to a wall TRX boundary condition, and then I can simply go and select these other 4 domains and assign them to a match TRX boundary condition. If you switch back to the TRX tab, you can see all your TRX parameters have been already set up. Last thing you have to do is basically hit the Solve tab and initialize your block. Now that the internal voxel block has been initialized, we can take a closer look. So I have a cut already defined in here. Let me go ahead and zoom in a little bit closer so we can see what we have. This is the same block that I showed you at the beginning of this video, and now you know how to create it. As we described before, you have the TRX portion of your block. Those TRX cells, anisotropic TRX cells, are growing off of the surface of the motherboard. Then you have the stitch layer connecting the TRX portion of your block to the voxel portion of your block, and there are these intermediate layers connecting the different layers of voxel blocks of different sizes. Those are called transition layers. You have one here and one here, and of course keep in mind there's one last zipper layer connecting the voxel portion of your block with those outer domains, which are unstructured in our particular case. So this is the final structure of your internal voxel block. So now that we know how to create that internal voxel block in the case of the quadcopter geometry with the motherboard, let's take a look at what happens when you actually click the initialize button. What is Pointwise doing behind the scenes? So let's take a quick look at this one. Of course, you start right here. The first thing that is going to happen is the TRX algorithm is going to run and is going to create the TRX portion of your block. At the end of that TRX portion of the block, you have the final front. So the voxel algorithm is going to have to populate that volume that exists between the final TRX front and the outer domains of the main surface of the quadcopter. So this is your starting point right here. So from there you move right here. So the first thing that the voxel algorithm is going to do is to construct an extend box around the entire grid. Then you move right here. The next thing the voxel algorithm is going to do is to construct the voxel cell inside the extend box. Then it's going to subdivide the initial voxel cell using the define max edge parameter. After that, it's going to construct the size field from domains and sources. In our case, there are no sources in this particular problem. The only thing that is going to affect the size field are all the domains involved. Moving along, the next thing the algorithm is going to do is to evaluate the size field at the cell centroids. After that, it will subdivide the voxel cells until they satisfy the size field. After that, it will subdivide the voxel cells until they satisfy the defined number for the transition layers parameter. In our case, if you remember, we used the default value of 3. Next to last step, the voxel algorithm is going to detect those cells that intersect the TRX front and the boundary domains. It's going to delete those cells, and it's also going to detect and delete those cells inside the TRX front and outside the boundary domains. So it will detect and delete those voxel cells. And the last step before the algorithm finishes is to create the zipper layers connecting the voxel portion of your block with the TRX portion of the block and also with the boundary domains. So that is what's happening behind the scenes when you click the initialize button on your voxel internal block. So a few voxel tips I want to give you before we wrap it up. Right here, the first one that I have for you is the range of voxel sizes can be adjusted by setting the appropriate min edge and max edge parameters, and of course you already know where to find those. Ideally, the mean edge and max edge parameters should be related by a power of 2. Last but not least, if you actually have islands of small voxel cells in your block and you don't want those, you could increase the mean edge parameter to try to get rid of them. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on Twitter, which is linked in the description. Thank you all and happy meshing!